What I want to discuss next is vector products. So the first one we'll discuss is the dot or the scalar product. So let's say we have a vector. We have different directions denoted here. We have the I hat direction here. This denotes the magnitude in the x direction. This denotes magnitude in the y direction, and this denotes magnitude in the z direction. So taking a dot product, we're going to multiply component wise. And what I mean by that is we're going to multiply x components by x components, y components by y components, z components by z components. Now, if you're doing advanced maths, you should know that the dot product of any component with itself is always going to be 1. So I hat multiplied by I hat is 1. That's how the dot product takes a vector out of it. V1 dot V2 is going to be 1 times 2, 1 times 2, x components, and then we have to multiply I hat by I hat. And similarly, we're going to have 3 times 3 in the y direction, and 4 times 9 in the z direction. Now we have I hat times I hat, j hat times j hat, and k hat times k hat. These all go to 1. We're left with 2 plus 9 plus 36, so our dot product is going to be 47. The bottom line is you just multiply the I hat components with each other, and the same with the j hat and k hat components. The cross product is a very specific product we can find in 3 dimensions. So if we took the cross product of these two vectors here, let's say that this is the x vector, this is the y vector. Well, if we go x cross product with y, what we'll have here is we want to go from x to y, so in this direction. If you take your right hand and point and curl your fingers around, and curl your fingers in the direction of this arrow, so that would mean that you're pointing your thumb downwards. In doing so, you're going to be pointing in the direction of the cross product. So the cross product of x with y is going to point downwards in this direction. Conversely, if we took the cross product of y with x, and we have y here and x here to get the x along the smallest angle, curling your right hand round in the same direction, your thumb's going to be pointing upwards. In doing so, that's going to be the direction of the cross product. So, how do we find cross products? Well, to do that, we need to find the determinant of the 3x3 matrix, given that the components here, I hat, j hat, k hat, look like this. So you'll discover how to do this later on when I cover determinants. It's not necessary to know now, but this is a quick method of finding the determinant of a 3x3 matrix. What we've done is we have just added on the first 2 columns to the right hand side of the matrix, and then use this simple mnemonic along diagonals to find the cross product. So just remember that the cross product of 2 vectors is always going to be orthogonal to the 2 vectors.